Hi everyone, welcome to Python Osmosis, episode 36, the screencast designed to provide you with the attributes you need in this instance. I'm Ryan Shea, and in this episode we'll be talking about classes. So hopefully I can do a good job explaining classes. I'm new to object orientation. Everything I've done before Python was very procedural. So let's take a look at what a class is in Python, and hopefully I can explain it well. So a very simple class would be class, car. And normally when you create a class, you use camel case. My car, you'd use a camel case like that. In this case, we only have one word, so car. And then it's always good to create a docstring that explains what the actual class is. And now you can do things like create attributes of a class. So wheels equals 4, def wheel count, self, return, self.wheels. Okay. So now we've created a very simple class called car. This is what's called an attribute, and this is what's called an attribute, but they're different kinds of attributes. This is a data attribute. And this function, is actually a class method. So if I looked at type car.wheels, this is just going to say an integer, and this one, car.wheelCount, is an instance method. So let's talk a little bit about what an instance means. With a class, you can reach right in and touch its data attributes. So wheels, if I wanted to call car.wheels, I could do that, and it returns 4. Now if I wanted to call car.wheelCount, you see it's expecting something to be sent to it, self. So if I just call car.wheelCount, it's going to yell at me. Unbound method wheelCount must be called with car instance as first argument. Got nothing instead. Okay, so how do I do that? I need an instance of a car. So to what's called instantiate a car, I would do Ryan car equals car. Whoops. Car. And you call it just like a definition, open, close, paren. You see that when I created this class, I didn't actually have to have an open, close, paren. We're going to talk about that a little bit later with inheritance, but a standard class, you don't need to actually inherit from anything. You don't need any parentheticals right here. So I call car. And now, if I look at whose, I see Ryan car is a car instance. Okay, great. So now I have a car instance. We can go back and we could call car dot wheel count Ryan car. So how many wheels are on Ryan's car? 4. Okay. Why is this useful? Why is this interesting? Normally you're not going to call wheel count this way. See, creating a class is sort of like building a new instance of an object, and your definitions are sort of like your verbs. You could drive a car, you could open a car door, you could whatever. And your attributes are sort of like the things about your car, the nouns, the make, the model, what have you. And when you instantiate a class, you're normally going to set some attributes straight away. So another way of calling with that self is I can say, in the exact same way that I did car.wheelCount and passed in this object, passed in this instance of a car, I can say Ryan underscore car dot wheelCount. This is called a method. I'm calling the method. Now look, I'm just going to open and close paren. I'm not going to pass anything into it. When you're using an instance of a class and you call a instance method, the actual object itself is always the first thing that's passed through. So it's implied. Wheel count expects a car type to be passed in to it, and I'm taking an instance of a car type and I'm calling wheel count, but I'm not manually specifying Ryan car here. I'm just specifying nothing. Because it knows that this is a car instance, I can just call it like a method. This is the same thing where, you know, we've used methods before on lists, on dictionaries. We've used append, we've used count, we've used all of these types of things. This is sort of like you can create your own methods of your own object type. Kind of cool. So let's do a little bit more of a practical example. Let's delete Ryan car. Let's delete car. We're going to create a new car. So class car. A car class. Okay. Again, wheels equals 4. We're going to do something here called a constructor. Underscore underscore init underscore underscore self. Again, all these definitions, you're going to want to have self as the first argument so that it allows everything that's done within that definition to be tied to the instance of that class. In other words, keep it private for that particular instance of a car. Ryan's car, Bob's car, Jim's car. You want to be able to do these things. You want to deal with that object separately. It's a new object. So self, and we're going to do make model. All right. Self.make equals make. Self.model equals model. We're going to talk about this in a second. Def, and we'll put that wheel count back in there. And return. Okay, so now when I create a car, Ryan car, I'm going to get a failure here. Init underscore underscore takes exactly 3 arguments, 1 given. So what does this mean? When I instantiate the car type here, Python automatically calls this special method called underscore underscore init. And I'm saying underscore underscore init expects a car object to be passed into it. That happens automatically. We don't have to explicitly state that. And it expects a make and a model to be passed in. When a make and a model are passed in, self.make, within the namespace for this particular instance, we're going to set the attribute make to whatever was passed in. We're going to set the attribute model to whatever was passed in. Then we're going to create this method wheel count. So now I can call this. I can basically, again, I don't have to explicitly pass self. I'm just going to say Honda, and I'm going to say Civic. Okay. Ryan car dot tab, and look at this. I've got a make, I've got a model, I've got this instance method, which is a wheel count, and I've got an attribute for wheels. So Ryan car dot wheels, Ryan car dot make model, and I can do the same thing. Bob car equals car. Toyota Prius. Okay. And you see, same thing. Wheel count, wheels, make, model. So now I have these 2 different self-contained objects. You can manually reach in and touch or create instance attributes. So for example, whoops, Ryan underscore car dot mileage equals 1. And now I have mileage, Ryan car. Let's do while Ryan car dot mileage is less than 10. Ryan car dot mileage equals Ryan car dot mileage times 2. Print car dot mileage 16. So I was able to manipulate that. Ryan car dot, you see I still have mileage. Now I could go through and I could say delete Ryan car dot mileage, and it's gone. Now none of this had anything to do with the parent class, with the actual car. Car still stayed the same. It just has wheels and wheel count. Let's take a look at an example that gives you an idea of the namespace. So let's create a new definition here, F1. Now notice I'm not in a class, but I'm going to say self x, y, return min x, comma, x plus y. And now I'm going to create a class, C, f equals f1. Notice that's outside. And def g, self, return hello world, and h equals g. So let's create an instance of this. X equals c. X dot. We have all of these unique attributes. We have f, we have g, we have h. So h is actually just another name for g. F is another name for f1, which was defined outside of the class definition itself. That's all for now. This screencast is directly inspired by the official Python tutorial by Guido van Rossum at python.org.